So question 1 on the maths trail starts off in our school, Patrician Presentation Secondary School, and it asks you, how many years has Patrician Presentation Secondary School been in existence? Well, it asks you to look at this pier here, and there's a date when Patrician Presentation Secondary School was established, and it was 1873. And if we take the year now, it's 2024, and we take 1873 from that, and we will get 151. So Patrician Presentation, as of now, as of the year 2024, is established 151 years. Question 2 then. Question 2 asks you to estimate the volume of the flower bed. So it's asking you to estimate, so you don't have to measure exactly. If you have a ruler, great, but if you don't, that's okay. But here is how you get the volume of, I suppose, a 3D rectangular prism. If you take the length of it, okay, so the length, let's say in this case it'll be centimeters, multiply that by the height, and then multiply your answer by the depth, which is how far back it goes. You will get an answer, and your answer will be in centimeters cubed, which is, and I'll draw centimeters cubed for you. There, that's about the size of a centimeters cubed. So if you're looking for the volume of that flower bed, it'll be in how many of these centimeters cubed it fits. Okay? Next question. It asks how many 4-digit codes can be made from the above numbers. So it doesn't ask you to list them all. It just asks you how many codes, right? But I'll give you an example of a code. We could have 1, 1, 1, and 1. We could have 1, 2, 3, 4. We could have 5, 4, 0, 3, etc., etc. And we're asked how many of these codes. And it does say each number can be used multiple times. So here's how we do this. It's 4-digit codes, right? So I'm going to draw 4 boxes representing each digit in the code. Now remember, the numbers can be repeated. So I ask myself, how many numbers are there all together in this? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So there's 10 numbers I can choose from for my first digit in the code. So I put in 10. My second digit in the code, again, I can choose 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0. So the 10 digits to choose from for my second number in the code. And yes, in my third number in the code, there's also 10 numbers I can choose from. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And for my last digit in the code, there's again 10 digits I can choose from. And what I do then to find out the total number of 4-digit codes that can be made from the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 is I multiply these. And if I multiply 10 by 10, if I multiply 10 by 10 by 10 by 10, I will get 10 by 10 is 100, by 10 is 1,000, by 10 is 10,000. So from those numbers, I can make 10,000 different 4-digit codes from them. The next question is inside the pavilion at Feathertown Park, and it's asking you the question, how many hours is Emily's coffee dock open for? That's the first question. So if you just look at this, and you can add up all the hours that she is open for. So if I add up, let's say 10 a.m. to 2:30 p.m., that's 4.5 hours. That's on a Tuesday, and then another 6 p.m. to 8 p.m. So on a Tuesday, she is open 6.5 hours. On a Wednesday, again, she's open 6.5 hours. Or 6.5 hours, or 6 hours 30 minutes. On a Thursday, Okay, so on a Tuesday she's open 6.5, on a Wednesday she's open 6.5. She's not open at all on a Monday. On a Thursday again she's open 6.5 hours. And on a Friday she's open 6.5 hours. On a Saturday then she's open 10 hours. And on a Sunday she is open 6 hours. So if you add all them up, okay, so in the weekdays she's open 26 hours, and on weekends 16. So 26 plus 16, the total she's open for the whole week is 42 hours. And then the next question is part of it. It says compare as a ratio the hours open on weekends towards the hours open during the week. Okay, so here's what you do. So for a ratio, we'll take the hours open the weekdays, and it's 26, and we'll compare them to the hours open on the weekend, which is 16. And to show it's a ratio, you put 2 dots in between. Okay. We could leave that as the answer, okay, but sometimes we like to simplify it. So we look for a number that will divide evenly into 26 and 13. So 2 will divide evenly into 26. Divide evenly into 26 and 16. So I know 2 will divide evenly into 26, and that will go in 13 times. Put my ratio sign, and 2 divides evenly into 6 8 times. So the ratio is 13 is to 8. That's the way we say it. Next question is regarding the Feathertown Park field. And it asks how many laps of the GAA pitch, the yellow perimeter, needs to be completed to run the distance of a marathon. And a marathon is 22.19 kilometers. So the first thing we do is we're going to find out how many meters the perimeter of the pitch is. And to do that, we will add the length, and then the width, and then the length again, and then the width of the pitch. Okay? Because the perimeter is all the 4 sides added up together. So the perimeter is 145 plus 90 plus another 145 plus another 90. If we add that up, we get 470 meters. So 470 meters is 1 lap of the pitch. In order then to find out how many laps, okay, and that's meters. This is 42.19 kilometers. So I need to divide this into this, okay? However, one is in meters, the other is in kilometers. So I need to change this 42.19 kilometers into meters. Okay, and to do that, I'll multiply this by 1,000 because there is 1,000 meters in a kilometer. So when I do multiply 42.19 by 1,000, I get 42,190. Okay, so now this is meters. So 42,190 meters in a marathon. The perimeter of a pitch is 470 meters. In order to find out how many laps of the pitch I have to do in order to run 42,190 meters, I divide the perimeter of the pitch, which is 470 meters, into the distance of a marathon, which is 42,190. When you do that, you get 89.77, correct to 2 decimal places. So in order to run the length of a marathon, you're going to have to do 89.77 laps of the Feathertown Park pitch. Okay. So the next question is the Feathertown Park car park. And it says how many car spaces is there altogether? You might disagree, okay, but based on my counting, I got 130. But feel free to look here and count and correct me. Then it says how many disabled car spaces are there, and I counted 8. And then it says calculate the percentage of disabled spaces compared to the total number of spaces. So how we do that is we take the total number of spaces, we make a fraction out of it, look. So we put the total number on the bottom, and then we put the amount of disabled spaces on the top, which is 8. So now we have a fraction. And to get the percentage of disabled spaces compared to total spaces, then we multiply our answer by 100. And I get 6.15, and that's a percent. Okay, so according to my calculations, 6.15% of the spaces in Feathertown Park are disabled spaces. Next question is by the Northgate Arch, okay, and it's an estimate this time. And it says horses are measured in hand, and a hand is 10.16 centimeters. Estimate how many hands high the arch of the road is. Now, unless we get a ladder and climb up, we're going to have to maybe see how high it is to here, okay? And then estimate, well, this is maybe half up to here, and then there's another few hands there. So it is an estimate, okay? So what you do is you'll go to the arch, you'll put your hands on top of each other like this. You'll see how many hands it takes to get to a certain point. Maybe a quarter ways up, and if you go a quarter ways up, then in order to get the full way up, you'll multiply by 4. Okay, but there's multiple different ways of doing this. And there's no one correct way, or there's no real incorrect way either, okay? And it's an estimate. The next one, so you're going to go to the AIB bank, and like the coffee shop in Feathertown Park, you're just going to add up how many hours the bank is open during the week. Okay, so I'm not going to do this one. I think you'd be well able to do this one yourself. The next question is to do with patterns. So it says the above pole has a pattern of alternate black and white. Patterns such as this are often called sequences. The sequence starts at the bottom of the pole and continues right up to the top of it. It says, is the first color of the sequence black or white? Well, you're going to have to find that out. What is the fifth color of the sequence? So again, you'll start in the bottom, count 5 up, and see what color it is. And then it says, if the pole extends further into the sky and the same sequence of black and white is continued, what would the 24th be? Well, I'm just going to take an example here, okay? But you're going to have to check it out and see if I'm right. So let's say the first color on the bottom of the pole is black, and then the second one will be white, and the third will be black, and the fourth will be white, and you're going to continue all that pattern until you get to the 24th, and you're going to see if it's a black or a white. Okay. Next question then is regarding reflections, and it's asking you in the letters that spell reflection, so REFLCTIONS, how many of them have an axis of symmetry? So an axis of symmetry is a line that can be drawn down through it to kind of give a mirror effect. So basically you have the same shape on two sides of the line. So I'll give you an example. D. So D has an axis of symmetry because if I draw a straight line across here, this bit is the same as this bit. It looks the same. A does. Okay, look. Same on both sides. And W does. F doesn't, because if I draw a line here, it's not the same on both sides. R here, R here, R here. Same with Z. You might think Z does, but it doesn't. Because if I draw a line across here, this is not the exact same as this. It's kind of flipped over. And the same with P. It doesn't have axis of symmetry. So if we look here, R doesn't have an axis of symmetry. The E in reflections on this one doesn't, okay, because it's like this. Okay, so I can't draw a line down the middle of that or across it to make it the same on both sides. However, if the E was like this and the middle line was straight down the middle, then I could, okay, because I just draw it here and it would be the same on both sides. And the F doesn't have an axis of symmetry. The C does. Okay, if I draw a line straight across here, it's the same on both sides. The T does. Okay, if I draw a line down the middle, it'll be the same on both sides. The I does. Okay, if I do an I here and I draw a line straight across it, It'll be the same on both sides. The O does. In fact, the O has infinite axes of symmetry, because I can draw a line anywhere as long as it crosses the middle, and it will be the same on both sides. The N doesn't. Okay, you might think it does, but it doesn't. Try it out. And the S doesn't. Again, it looks as if it might have an axis of symmetry, but if you try it out, you'll see it doesn't. Next question is down by the Abbey Mill, and it's asking you measure in hands, centimeters or meters, and calculate how many times the diameter of the circle. Diameter is a line that goes straight across the circle from one side to the other and crosses the middle, would wrap around the circumference, and the circumference of a circle is all the way around the circle. Essentially, it's perimeter. Okay? If you do it, you should get about 3, or maybe a little bit more, maybe 3 and a bit. Well, if you measured it really, really very, very precisely, you would get 3.14. That's correct, 2 decimal places. And that is a thing called pi. So in every single circle, the diameter wraps around its circumference 3.14 times, which is pi. And that's where we get pi from. Okay, so try it out, see what you get. The next question is just right beside the Abbey Mill. Okay, it says, why is the door so low? It wasn't always like this. Over the years, the ground around the church has risen or been built up. Then it says, find how high the ground around the church has risen. What you'll do is, you look at the ground here, and you'll just draw an imaginary line across, and then you'll see what the distance is from here right down to the end of the door. If you find that distance, that measurement, you'll know how much the ground has been built up around it. Okay, this is a really interesting question, and it's actually in the film Die Hard with a Vengeance. Okay, it says you have unlimited water, so you have as much water as you want, and you have 2 plastic containers. There's no measurements on these containers, so you don't know when it's half full or a quarter full. But what we do know is when one container is totally full, it holds exactly 500 milliliters, and when the other container is exactly full, it holds 700 milliliters. We're allowed to put water in the container, spill water out of the container, put water in one container and put it into the other, and vice versa. But we only have 2 containers. We've unlimited water, and at the end we want to be able to have exactly 100 milliliters in the container. This is how we do it. We take our 500 milliliter jug and we fill it up to the top. So there's 500 milliliters in that. And then we pour that in here. So there it is, 500 milliliters. That then is empty now. We fill it up again, so there's 500 in here. And we pour as much of it as we can into this. Now remember, this total, when it's full, will take 700 milliliters. So we can pour as much of as we can into this, and all that fits in is 200 milliliters. So that means we have 300 left in this. Now what we do is we spill out all this water so that there's nothing in this. And the 300 we had in that, we pour it in here again. 300 milliliters. Now there's nothing here. Then we fill this all the way up to the top again. Remember, 500 milliliters fits in this when it's full. And we start pouring here. And we already have 300 milliliters in it. So all that will go from here to here in order to fill this is 400. There won't any more fit. And if we pour 400 milliliters from the 500 bucket, we will be left with 100 milliliters in this, and we'll be after answering the question. Okay. Next question is down by the town wall, and it says in any 45 degree angle, its base is always the same as its height. So for instance, any 45 degree angle, okay, or triangle, this line here will be the same length as this line here, provided that this is 45 degrees. Okay? Knowing that, we can solve a lot of problems. So we're looking for the height of this wall where x is. So we're looking for the height of that. We're told that from this point up this direction makes a 45-degree angle. So by that logic, we don't have to climb that wall to see how high this is. All we have to do is measure from here out to this point in the grass. And we know then that whatever this measurement is here from the wall to the grass will be the exact same as that height. So no need to climb, just measure from the base of the wall out to the grass. Okay? And it makes a 45-degree angle, so we know that that will be the same as the height of the wall in this case. Right, the next one. So you have a bit of fun with this one. Just want to draw something up. When we want to measure speed or distance or time, we use this triangle. Okay, so we have speed, distance, and time. Okay, so I hope you can read that. D on the top stands for distance, speed, and time on the bottom. So what you do, if I want to measure my speed, okay, so I'll cover this, and it will be, if we look, I'll cover this section here, this corner, and it's distance, and that's on top, and time is on the bottom. So basically I get the distance, and I put the time on the bottom, I create a fraction, I divide one into the other, and it will give me my speed. So what you do is, you measure, up here, you measure where you're starting, and where you're finishing. So you measure that distance, okay? Whatever that distance is then, you're going to put it on the top of the fraction. So I don't know what it is, but let's just say it's 30 meters. Okay, then you're going to get your stopwatch. And you're going to start over here on the zipline. And you're going to go, and you're going to get someone to time you. So how long it takes you to get from here to over here. And let's say it takes you 10 seconds. Okay, now you have a fraction with 30 on the top and 10 on the bottom. You divide the 30 by 10 and you get 3. And that's 3 meters per second. So that's your speed. So try it and see how fast you can go. This next question is just like the last one. Remember the one with the numbers and how many combination codes could you do from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? This is the same, but it says how many different ways can you arrange the letters post? Okay, well, watch this. We have to use all the letters. I draw 4 boxes. How many choices have I to go into this box? Well, I can put in P, or O, or S, or T. Okay, so I have 4. However, there's a little difference in this one. Okay, I can't use the letters more than once. So if I put P into this box, that's gone. Okay, so watch. I'm after using P, so it's gone. So now I go to my next box, my next letter. And how many choices have I to go into that? Well, I'm after using one of the letters. Might have used P, might have used O, might have used S, or might have used T, but one of them is gone. So now I only have a choice of 3 to go into the next box. And let's just say I put in S there. And now in my third box, I only have a choice of 2 letters. In this case, O and T. And I use, let's say, the O. And lastly, then I've only one choice. Okay. And what I do then is I multiply all of them, and I get 4 by 3, which is 12, multiplied by 2, which is 24, multiplied by 1, which is 24. And that will give me the total number of ways that I can rearrange the letters P, O, S, T. Okay, remember, the last one, I had 10 in each box, but that's because I could repeat the numbers. In this one I can't, okay, because I'm rearranging the letters. Okay? Okay. So the next one then, there is a signpost from Feathered and its direction is to my glass. And it's asking you, in the length of furlongs, how long is it from feather to my glass? And it's telling you in the question that there are 5 furlongs in a kilometre. So how you're going to find out how many furlongs it is to my glass, you're going to check this sign, you're going to see how many kilometres it is. And when you find out how many kilometres it is to my glass, then you're going to multiply that number by 5, because there's 5 furlongs in every kilometre. So let's say it was 2 kilometres to my glass. Well, to find out how many furlongs will be, you'd multiply the 2 kilometres by 5 and you get 10. If it was 3 kilometres to my glass, you'd multiply the 3 by 5 and it would give you 15 furlongs. Okay, so check the distance in kilometres and then multiply it by 5. Okay, so the next one, there's a scales for weighing cattle, and it's asking you, first question, what is the maximum it can weigh at once? And there's the hint, it's written on it. Okay, and when you go there, you'll see that it can weigh 6 tons. Okay, it says then there is 1,000 kilograms in a ton. Okay, so it can weigh 6 tons. There's 1,000 kilograms in a ton, so it can actually weigh 6,000 kilograms at once. The question is, the average racehorse weighs 450 kgs. So what is the maximum amount of horses this scale could weigh at once? So all we do is we take our 600 kg, which is the max weight that can go on it. We divide the 6,000 kg by 450, because that's the average weight of a horse. And we get 13.33. So that can have 13.33 horses on it on average at once. However, we don't really have 0.33 of a horse, so I would be saying it can take 13 horses at a time if you could fit them all. Okay. And that's all the questions answered. I hope you had fun with the maths trail, and I'd just like to thank all the students of Patrician Presentation Secondary School who put loads of hours work into designing this, and so well done to all of them. Thank you.